Okay guys, so this is going to be our last set of notes that go with test 3 material over moles, percent composition, and empirical formula. So this is your empirical formula notes. An empirical formula gives the lowest whole number ratio of elements in a compound. For some compounds, the empirical formula and the molecular formula are the same. So I'm going to tell you what a molecular formula is down here, okay? But it's the same exact steps. There's just one extra little step. Okay, so all these problems have the same steps, okay? Your first step is to convert each one of these elements to moles, okay? So we go 11.775 grams of SN over 1. And we go through the molecular weight. So 10 SN has a weight of 119 to 1 mole of SN. And then oxygen has a weight of 16. You should all know oxygen's weight by now. Now, we're not going to use diatomic oxygen because it says O, okay? So make sure you don't do diatomics on that. So what we do is we're gonna put these numbers in the calculator, okay? So we're gonna do 11.775 divided by 119, and you get 0.0989. So go 4 decimal places. Okay, and then moles of SN. And then we're going to do the same thing over there. So we'll do 3.18 divided by 16. We get 0.1988. Okay, moles of oxygen. Now, from there, if you have 2 or 3 elements or however many elements you have in the compound, you pick what is the lowest number. Crap, I didn't fix that. Okay, sorry. You pick what's the lowest number out of these 2 results. So the lowest number is going to be 0.0989. So we're going to divide everything through by the smallest number result we get. This divided by this is 1. And 0.1988 divided by 0.0989 is 2. Okay, something really close to 2. So we're going to call that 2. Okay, so our empirical formula is going to be, we have 1 SN and we have 2 oxygens. That's it. Okay, find the empirical formula for a compound containing 43.7% P and 56.3% oxygen. Okay, so when we do this, percentages we're going to treat as grams, okay? So do it exactly the same way as we did the previous problem. So 43.7 grams of P, and phosphorus weighs 31. And we do 56.3 grams of O. Oxygen weighs 16 grams. Okay, so we put those numbers in the calculator and we're gonna go 4 decimal places. So we get 1.4097 moles of P. And then we get 56.3 divided by 16, and you get 3.5188. Okay, out of these 2 results, which one's the smallest? Well, this is the smallest. So we get 1.4097. And then we're going to divide this by 1.4097 also. So we get a 1. And then that divided by 1.4097. You get 2.0 Okay. Now, we're something really close to 2.5. So we get 2.496. Okay. Now, what I'm going to tell you, we're going to make a little note of this out to the side. If we'll do it up here. If I see 0.5, 0.5 is 1/2. So we're going to multiply by 2. Okay, that's how we get rid of that fraction. If I see 0.333, something really close to that, that's 1/3, so I'm going to multiply by 3. 0.25 is 1/4. Oop, so we're going to multiply by 4. And then 0.166 times, we'll multiply by 6. Okay, that's 1/6. Other than that, those are your most common ones. You really probably won't have to use the last two, but I just wrote them down just in case. Okay, so that's if we get something close to it. Okay, so in that case, we had 2.49 something. So we're going to call that 2.5. Okay, so how do I get rid of a 0.5? Well, I have to multiply everything through by 2. Okay, so this is going to be P2O5. Okay, so once again, if you get a 0.5, you have to multiply both numbers by that. Words of advice. When you divide, if you don't get something really close to a whole number or one of these decimals up here, you probably messed up. Okay, so go double check your calculator work and your molecular weights, or if you wrote the problem down wrong. Okay, I've corrected this like 9 million times. Obviously did not correct this. This should be, find the empirical formula of a compound that is 85.7% carbon. Okay, I'll correct it for you whenever when I post the notes. It'll be corrected for y'all. Okay, so I have 85.7% carbon and 14.3% hydrogen. It has a molecular mass of 28. So we're going to go through the first few steps just like we did before. So 85.7 grams of carbon. Okay, so percentages we write as grams. Carbon has a molecular weight of 12. Okay, and then you have 14.3 grams of hydrogen. Hydrogen has a mass of 1. Okay, so 85.7 divided by 12 is 7.1417. Okay, and 14.3 divided by 1 is 14.3 moles of H. So we're going to divide through by the smallest number. So we're going to divide by 7.1417 and 7.1417. Okay, so we get a 1, and this should come out to be 2. So we're something really close to 2. 14.3 divided by 7.1417. And you get 2.00, which is 2. Okay? So your empirical formula is CH2. Now, anytime we have a mass, so it says it has a molecular weight of 28, a molecular mass of 28, we have to do something called check the weight. Okay? So we're going to check the weight of this. Carbon weighs 12, and you have 2 hydrogens at 1 each. So this has a molecular weight of 14, right? So what we're going to do is if our molecular weight does not match this, we're going to have to manipulate it, okay? So 28 divided by 14 is equal to 2. So what we're going to have to do is double everything in this empirical formula. So C2H4. Okay, so we get the molecular formula for this is going to be ethylene. Okay, so this is the empirical formula. And this is going to be, oh, I keep hitting my camera, is your molecular formula. Okay, So you will have a question like this on your test. So you need to make sure that you know how to operate the empirical formula and the molecular formula. So what's different is we get our empirical formula. We check the molecular weight. I got my molecular weight was 14. I need to get to 28. So how do I do that? I multiply by 2. Okay. So, and if I wanted to double check my molecular weight at the very end, 2 times 12 is 24, plus 4 gives you 28. Okay, last one of these. And then we'll go on to the empirical formula worksheet in the next video. Okay, find the empirical formula for a compound that is 48.8% MgSO4 and 51.2% water. Okay, so same procedure, 48.8 grams of MgSO4. Okay, so we're going to have to go through the molecular weight of that. So Mg weighs 24. Okay, sulfur weighs 32. And you got 4 oxygens at 16, which is 64. So we're going to add those together. And we get 120 grams. Okay. Now, from our previous lesson, we know that water weighs 18. So we're just going to say 51.2 grams of water over 1. Water weighs 18 grams. Okay, so we're going to put those in our calculator. So 48.8 divided by 120, 0.4066 moles of MgSO4. Okay, and then 51.2 divided by 18 gives you 2.844 moles of water. Okay, so we're going to divide through by the smallest number. Okay, so we get a 1 right here. Anything divided by itself is 1. And then 2.844 divided by 0.4066, you should get 7. Okay. So when we go to write, this is going to be a hydrate. So we talked about what hydrates were last class. Hydrates are going to be compounds that contain water. Okay, and we drive the water off. So when we go to write this, empirical formula is going to be MgSO4 dot, and then we have 7 waters. Okay, and we didn't have to check our weight on that one because it doesn't give us a molecular weight. Okay, so that's our empirical formula. If you have any questions, feel free to reach out, and I'll come back with you with the empirical formula worksheet. Thanks, and have a good one.